Yeah. Let us complete the similar triangles based on basic proportionality theorem. Here, the side BC of triangle ABC is bisected at D. Side BC of triangle ABC. Side BC of triangle ABC bisected at D. That means here it is D. O is any point in AD. O is any point in AD. BO and CO produced to meet AC and BD. BO means like this. BO and CO produced meet AC. CO. BO and CO. What is given? BO and CO produced meet at AC and AB. AC and AB in E and F respectively. E and F respectively. AD is produced to X. AD is produced to X. So that D is the midpoint of OX. D is the midpoint of OX. Next, prove that prove that AO by OX is equal to AF by FB is equal to AE by AC. And show that EF is equal to EF is parallel to EBC. This is second case. So here what is given is triangle ABC is there, in which O is any point on AD. O is any point on AD, and side BC of triangle ABC is bisected at D. Bisected at D means this length is equal to this length. Next, side BC is given of a triangle ABC is bisected at D. D means D is the midpoint, and O is any point. O is any point on AD. O is any point on AD. BO and CO are produced to meet E at AC and F at AB respectively. Respectively means accordingly, and AD is produced to X such that OD is equal to OX. Now what you have to do? Join this. RTP required to prove. This is RTP construction. Join, what you can say, join BX and CX to complete parallelogram. Why we have to join? Because this since OD is equal to, you can write here proof, no problem. Proof, join BX and CX to complete parallelogram. Since why we have to do to complete parallelogram? What is the meaning of this? Since OD is equal to DX, also BD is equal to DC. Diagonals bisect each other. Since OD is equal to DX and BD is equal to DX, diagonals bisect each other. That is the meaning. So therefore this forms a parallelogram. Next, if this is a parallelogram, this side, this XC is parallel to OB. Therefore CX is parallel to OB. CX is parallel to OB. Right? Now consider this triangle. CX is parallel to OB. In this triangle, you can write it as Consider triangle ABX. ABX. Or else another way, OC, CO is parallel to BX, right? CO and also CX is parallel to OB, also OC is parallel to BX, also OC is parallel to BX means OF is also parallel to BF. This implies OF, OC, CO is parallel to BX means what I am saying is OF is also parallel to BX, right? From these two, OC, CX is parallel to OC is parallel to AB, that means OF is also parallel to BX. Consider this also you can write CX. Here you can say CX is parallel to DO means OE is also parallel to, this implies CX is this one. CX is parallel to OB, that means OB is, that means OE is also parallel to XC, like this. CX is parallel to OB, CX is parallel to OB means OB is parallel to CX, also OE is parallel to CX. Therefore, consider triangle ABX. Consider triangle ABX. Very important, this one, this part, ABX. ABX. Now what is given? OF. See here, OF is parallel to BX. Apply BPT. If a line is drawn parallel to one side of a triangle, then this line divides the other two sides in the same ratio. This one, for this triangle, this is the line parallel to this one. OF is parallel to this one. If a line is drawn parallel to one side of triangle, it will divide the other two sides in the same ratio. That means AF by BF is equal to AO by OX. So it is AO by OX is equal to AF by BF. Once it is proved. Next, also consider this triangle. Also consider triangle AXC. AO by OX. Already again OE is parallel to XC means if a line is drawn parallel to one side of a triangle, it will divide the other two sides in the same ratio. By BPT, basic proportionality theorem. Triangle AXC means AO by OX is equal to AE by EC. So club these two, AF by FB from 1 and 2. It is also by BPT, basic proportional theorem. Now AF by BF is equal to AO by OX. But what is AO by X? AE by EC is equal to AE by EC. Therefore, first one is AE by EC. AE by EC, this is required to prove AE by EC. Next, it is wrong given AE by EC. Next, from 1 and 2, this is over. Now consider triangle ABC. In triangle ABC, join this. From this, what we can say, AF by BF. Consider triangle ABC. AF by BF is equal to AE by EC. This is what given, AE by EC. So AF by FB is equal to AE by EC from Roman numeral 1. Therefore, by converse of BPT. What is the converse of BPT? The line divides the other two sides in the same ratio. That means this line is dividing this side and this side in the same ratio. AF by FB is equal to AF by FC. By converse of dpt, a line divides the other two sides in the same ratio. AF by FB is equal to AF by FC. Therefore, EF is parallel to BC. There is the solution. Here it is given no AO by OX. What I am saying is AF by FB is equal to AE by AC. So this is the line dividing the other two sides in the same ratio. Therefore, this EF is parallel to BC. Hence the theorem. Very, very important, which is tough also. Next. Another one, in the given figure, see, look at this. They will only given figure. They will only give the figure A, B, C. E is the midpoint of BC. That means they are given E is the midpoint. E is the midpoint of BC and CD is equal to half AC. See somewhere here. CD is equal to half AC. This CD is equal to half AC, it seems. CD is equal to half AC. That is given. E is the midpoint. Given E is the midpoint of BC and DE meets AB at F. DE means DE meets AB at F. DE meets AB at F. DE meets AB. DE meets AB at F. EQ is drawn parallel to AB. EQ. This is just a rough diagram. EQ is drawn parallel to AB. So what we have to prove? Prove that EF is equal to RTP. RTP is equal to EF is equal to 1/3 DF. EF is equal to 1/3 DF. How to do this one? Very simple, children. Let us calculate first what is given. CD is equal to half of AC given. And proof. E is the midpoint and also E is midpoint. Also EQ is parallel to, this is given, no? EQ is parallel to given. This is CD is equal to given. EQ is parallel to AB given. This EQ is parallel to AB and also E is the midpoint of this. EQ is parallel to AB. Therefore, what can we say? The line segment joining the midpoint of one side of triangle parallel to the third side also bisects the another side. If the line segment joining the midpoint of one side of a triangle parallel to the third side bisects the other side. So since E is the midpoint and EQ is parallel to AB, this Q becomes a midpoint. Therefore, Q is the midpoint of AC. Why? Because by previous theorem. What is that theorem? What is that theorem suggest? If the line segment joining the midpoint of one side of a triangle parallel to the third side, parallel to the base, bisects the other side. That is the theorem. Therefore, what can you say? Q is the midpoint of AC. Therefore, AQ is equal to QC. AQ is equal to QC, that is equal to half of AC. Both AQ is equal to QC, both are same, both are equal to half of AC. Now consider this part. So CD is also equal to half of AC given, right? Here what is the theorem, why you have written like this means, why Q becomes a midpoint is, in a triangle, this is the triangle PQR. If you take a midpoint of like this and if you draw a line parallel to this side, then it will bisect this side. Then it will bisect the line segment joining the midpoint of one side of a triangle parallel to the third side bisects the other side. That means PEAQ. Therefore, here it is B becomes the midpoint. That is the theorem. So therefore, CD is equal to half of AC, like that. So AQ is equal to QC is equal to half of AC, CD is equal to half of AC given. Next, consider triangle ABD. Consider triangle AFD. What do you use the basic proportionality theorem? DE by EF is equal to the line saying DE by EF is equal to DQ by QA. What is DE? You write as it is DE by EF is equal to DQ. DQ is nothing but QC plus CD. DQ is nothing but QC plus CD. QA is nothing but QA, here we have written AQ is equal to half of AC. What is QC? QC is equal to QC, here we have written QC is equal to half of AC. CD is what? Half of AC plus half of AC by half of AC. Half AC plus half AC is AC. AC by half AC. AC cancel. So therefore, DE by EF is equal to 2. Is equal to 2. Therefore, DE is equal to 2 times EF. DE is equal to 2 times EF. We have proved DE is equal to 2 times EF. Now, therefore, DF is equal to DE plus EF. DF is equal to, what is DE length? 2 times EF plus EF. DF is equal to 3 times EF. Right? So EF is equal to, bring this one, 1/3 DF. 1/3 DF. That is the theorem. Understood? Once again, I told no, the line segment joining the midpoint of one side of a triangle parallel to the base bisects the opposite side. So therefore, E is the midpoint, Q becomes the midpoint, and also therefore consider triangle AFD, CDE by EF is equal to QC by, and I applied that one and we got the result like this. So with this basic proportionality theorem completed. Thank you students. Have a nice day. Bye. We'll meet you in the next class. Bye.